Welcome to Galactic Secrets. Today, we're taking a deeper dive into the mysterious and mind-bending concept of time travel, stretching the boundaries of what we know about space-time and even the speed of light. Could time machines ever become real? How does traveling through time work, and what happens when we push beyond the boundaries of space and light? We'll discuss the science, the theory, and the imaginative possibilities of traveling not just across time, but through space itself. But before we embark on this fascinating journey, make sure you hit that subscribe button, ring the notification bell so you never miss an episode, and share this video with your friends and family. Ready to unlock the secrets of the cosmos? Let's dive into time travel. Part 1. The reality behind time travel. From science fiction to science fact, time travel is often considered the realm of science fiction, but its basis lies deeply rooted in physics. The concept of moving through time has fascinated humanity for centuries, with books like H.G. Wells' The Time Machine, and films like Back to the Future capturing our imagination. But is time travel really possible? The key to understanding time travel begins with Einstein's theory of general relativity, which revolutionized our understanding of the universe. Einstein discovered that space and time are part of a single, intertwined fabric known as space-time, and that massive objects, like stars and planets, warp this fabric. The warping of space-time can lead to strange effects on time itself, like time dilation, which we'll explore in detail shortly. Scientists believe that time travel into the future is not only possible but already occurring in small ways. Astronauts aboard the International Space Station, for example, experience time more slowly than people on Earth due to the relativistic effects of their speed and lower gravity. But time travel into the past? That's where things get complicated. Part 2. Time dilation and the speed of light. A key concept in the science of time travel is time dilation, an effect of moving at speeds close to the speed of light. According to Einstein's special theory of relativity, the faster you move, the slower time passes relative to someone who is stationary. At speeds approaching 299,792 kilometers per second, the speed of light, time would slow down dramatically for a traveler. For example, if a spaceship could travel at 99.99% of the speed of light, the crew might age just a few years, while centuries would pass on Earth. This is a direct form of time travel to the future. However, reaching the speed of light is no small feat. According to current physics, accelerating an object with mass to the speed of light would require an infinite amount of energy, making it impossible with today's technology. Still, scientists are researching hypothetical methods to bypass these limitations, including warp drives and tachyon particles, which we'll discuss soon. Part 3. Wormholes, a shortcut through space and time? Wormholes are theoretical structures in space-time that could provide a shortcut through both space and time. If they exist, wormholes could connect two distant points in space or even two different moments in time, allowing for instantaneous travel. While wormholes are predicted by Einstein's equations, no one has ever observed one directly. In theory, a traveler could enter one end of a wormhole and emerge on the other side in a completely different time or location. The idea of a wormhole time machine is incredibly appealing because it could potentially allow us to travel both into the past and the future without needing to move at the speed of light. However, there are significant challenges. One of the biggest is that wormholes may require exotic matter with negative energy to remain stable. Without this, any wormhole that forms might collapse before a traveler could pass through it. Still, some physicists believe it might be possible to stabilize a wormhole artificially, which could lead to breakthroughs in both space travel and time travel. Part 4. Time travel in space. The complexity of space-time. Space and time are inherently linked, which means any form of time travel would also involve space travel. This is because Earth, and everything else in the universe, is constantly in motion. Our planet is rotating on its axis, orbiting the Sun, and our solar system is moving within the galaxy. Imagine you travel back in time by just a few hours. Earth would no longer be in the same position it was when you left, so your time machine would need to account for the shifting coordinates in space-time. This adds an entirely new layer of complexity to the idea of time travel. Instead of just focusing on moving through time, We'd also need to account for the exact location of planets, stars, and galaxies at any given point in the past or future. For this reason, some scientists argue that time travel will require the manipulation of space-time as a whole, not just time alone. If we can learn to warp both space and time together, perhaps through gravitational manipulation or other unknown means, we might unlock the true potential of time travel. Part 5. Exceeding the speed of light, the final frontier for time travel? According to relativity, nothing can travel faster than the speed of light, at least not through conventional means. But what if there were ways to bend the rules? Some physicists have proposed theoretical ideas, such as the Alcubierre warp drive, which could move faster than light by bending space around it. The Alcubierre drive works by compressing space in front of a ship and expanding it behind the ship, creating a warp bubble that allows it to travel vast distances at faster than light speeds. Importantly, the ship itself doesn't move faster than light within the bubble, meaning it could bypass relativity's limits. If such technology were possible, it could open the door to time travel in ways we can only imagine. Moving faster than light could theoretically allow for the reversal of time, opening the possibility for journeys into the past. However, achieving this kind of technology remains speculative, and would require breakthroughs in exotic physics. Part 6. Paradoxes and the consequences of time travel. While time travel may be possible in theory, it raises many profound questions about the nature of causality. One of the most famous examples is the grandfather paradox. What happens if you go back in time and prevent your grandfather from meeting your grandmother? If they never meet, how can you exist to go back in time in the first place? Another interesting dilemma is the bootstrap paradox, where an object or piece of information has no clear origin. Imagine you travel back in time and give yourself instructions that you received in the future. Where did those instructions come from originally? These paradoxes challenge our understanding of cause and effect and suggest that if time travel is possible, the universe might behave in ways that defy our intuition. One potential solution to these paradoxes is the idea of parallel universes or the multiverse. According to this theory, each time a time traveler alters the past, they create a new, branching timeline. This would allow you to change the past without affecting the future you came from, potentially resolving the paradoxes. Part 7. Quantum time travel. How quantum physics could help unlock time's secrets at the smallest scales. The rules of the universe change. Quantum mechanics, the branch of physics that governs particles smaller than atoms, allows for phenomena that seem impossible in our everyday world. Particles can exist in two places at once, and quantum entanglement can link particles across vast distances. Some physicists believe that quantum mechanics could hold the key to understanding time travel. For example, quantum superposition allows particles to exist in multiple states at once, suggesting that time may not be as linear as we think. Additionally, quantum tunneling allows particles to pass through barriers they should not be able to cross, hinting at the possibility of bypassing the usual flow of time. There's even speculation that quantum systems could serve as a kind of natural time machine, allowing us to send information back and forth through time. While this is still a long way from practical time travel, the strange behavior of particles at the quantum level suggests that time itself may be far more complex than we currently understand. Part 8. Pop culture and the science of time travel. The idea of time travel has long fascinated audiences in movies, TV shows, and books. From the DeLorean in Back to the Future, to the TARDIS in Doctor Who, pop culture has provided endless examples of how time travel might work. These fictional explorations often ignore the complexities of space-time physics, but they also inspire real-world scientists to ask the big questions. Many of today's leading time travel theories, including the concept of wormholes and time dilation, were popularized by science fiction before they became serious topics of scientific inquiry. So, could the next big breakthrough in time travel science come from the imagination of today's writers and filmmakers? Only time will tell. Part 9. The future of time travel. What's next? As we explore the cutting edge of theoretical physics and delve into the mysteries of quantum mechanics, we may eventually unlock the secrets of time travel. The journey is far from over. Whether we develop time machines, travel to the future via relativistic speeds, or discover new ways to bend the fabric of space-time, One thing is certain. Time travel remains one of the most tantalizing possibilities in the realm of science and technology. Could time machines be a reality in the near future? Will humanity ever travel back in time to relive the past, or explore the farthest reaches of the future? Let us know what you think in the comments below. And if you're as fascinated by time travel and the mysteries of the universe as we are, be sure to subscribe to Galactic Secrets, hit that notification bell, and share this video with your friends and family. Until next time, keep your eyes on the stars, and never stop exploring the unknown.